Hello friends, this is the session regarding Euler's modified method. Now this is Euler's formula. Yn plus 1 k is equals to yn plus h f of x0 y0, and Euler's modified formula is yn plus 1 k plus 1 equal to yn plus h by 2 f of xn yn plus f of xn yn plus 1 k. Now this Euler's modified method under the numerical technique, this we are using to solve differential equation first order first degree dy by dx is equals to f of xy, where function is defined here x plus y square, x minus y, x cube minus y cube, and so on, with initial condition y of x0 equal to y0. We can solve such a type of differential equation with this initial condition by using Euler's modified method. And in some problems it may be asked to find out y of 0.1 which is equals to, or y of 0.2 is equals to, so some value like this they can be asked regarding this Euler's modified method. Now this method will discuss first example 1, given that dy by dx is equals to x plus y square with initial condition y of 0 equals to 1. Find this value y at 0.02. Now initially we'll make this table to understood what iteration we have to find out. So x0 value is 0. From this position we'll define x0 is 0. From this position we'll define y0 equals to 1. Now x1 value is nothing but x0 plus h. So x0 value we have 0, h, this value we have to assume if it is not mentioned in the problem. So for that here we consider 0.02 and x1 equal to 0.02. Now for this x1 value we have to find out first iteration, that is y1 value. So we have put here question mark. After the completion of problem we will put here this value. Now in this problem first we will use by Euler's formula. So here we have written Euler's formula yn plus 1k, this is the formula. In this formula substitute n equals to 0, k equals to 0. So this formula become y1 of 0 and this expression. Now all these values we know that from the table format. So substitute y0 value 1, h is 0.02, x0 value 0 and y0 is 1. Now this is a function f of x comma y, and the nature of function from this will define x comma y. So it is x plus y square. So this we can write f of x comma y 0 plus 1 square. So this is the position of x, this is the position of y. So 0 plus 1 square. So after simplification of this, now we got here y1 of 0. So this value it is 1.02. Now the second part for this problem is we'll discuss by using Euler's modified formula. So this formula we have written here yn plus 1 k plus 1 is equals to this expression. Now in this formula substitute n equals to 0, k equals to 0. So this formula become y1 1 y0 h by 2 f of x0 y0 plus f of x1 y1 of 0. Now we have not directly use this Euler's modified formula only because of this term y1 of 0, because this value is unknown and this value we have discussed before in part 1 by Euler's formula y1 of 0 equal to 1.02. So this value we required here in this Euler's modified formula. Now we substitute all these values in this formula, and so that the expression become for y11. Now we substitute all these values in this formula of y11. So y0 value, again all these values from the table format we know that, and the last value y1 of 0, this we substituted from Euler's formula, so 1.02. Now this expression we have simplified f of x comma y, it is x plus y square. Similarly f of x comma y, it is x plus y square. So this calculation if you simplify it on calci, now we have the answer y11 is equals to 1.021. So this is the first iteration y1, and this one is the first approximation for that iteration. Now this we have find iteration 1 with this first approximation. Similarly, if we substitute n equals to 0, k equals to 1 in Euler's modified formula, so that formula become y1, that is the first iteration, and this is the second approximation for that first iteration, y0 plus h by 2, so it becomes this formula. All these values we know that from the formula table format, so substitute in this. Y11, this we already have calculated, so substitute that value here, calculate this, and so that first iteration for that second approximation, this value become 1.0206. Now if we compare y11 and y12, so they are approximately to be same for two decimal places. So always we have this conclusion, and this second approximation will declare this is the value of y1 and will complete our table. So y1 it become. Now this approximations we can continue for y11, y12, y13 and so on. So the more approximate value for the first iteration that we'll get by using these approximations. So this is all regarding Euler's modified method. If you like this video, please subscribe this. Thank you one and all.